Today we're going to continue on with 2.6, talking about implicit differentiation. Yesterday we learned how to take a derivative of an equation when we can't solve it explicitly for y, getting it to be y equals. And when we take the derivative of something with y in it, we have to basically use the chain rule and think of y as some type of expression of x. So if we were to take the derivative of something like this, 5x minus 7 to the third, if we were doing the derivative of that, we would use the chain rule, which we've been doing for a few days now. We would have to take the derivative of the outside, the cubed part, and then deal with the derivative of the inside. So we'd have 3 times 5x minus 7 squared, then multiply by the derivative of the inside, which would be 5. Well, similarly, if we're taking the derivative in terms of x of y cubed, well, this is not in terms of x. It's not just a plain old x cubed. Just like here, this was not just a plain old x to the third. We had to take that into account. Well, when we do this derivative, we bring that 3 out in front, subtract 1 from the exponent. So the cubed is like our outside function. The inside function is the y. We don't really know what that is in terms of x, and we're doing our derivative in terms of x. So we have to multiply by the derivative of this inside part, which is the derivative of y with respect to x, or dy dx. So this dy dx is kind of like our 5 from this problem, the derivative of the inside. So keep that in mind when we take the derivative in terms of x of something that's in terms of y. Let's go ahead and take a look at number 1. Directions ask us to find the slope of the tangent line. Remember, that comes from the derivative at the point P. So we need to figure out the derivative of this. This is one where we cannot solve it for y first and then take the derivative. So what we're going to do is take the derivative as it is. And since this first part is y squared, we're going to take 2 times y to the first, but then we have to multiply by the derivative of y, which is dy dx. Minus, this is all in terms of x, so that's fine. We're just going to get 8x. And our derivative over here is just 0, because the derivative of a constant is 0. Now, after we've gone ahead and taken the derivative of both sides, now we need to try and get dy dx by itself. So there's only one of them here. We don't have to get them all on one side. This is here already, so we want to get everything else out of here. So I'm going to go ahead and add 8x to both sides. So we have 2y dy dx equals 8x. And then we can divide both sides by 2y. And we get dy dx equals 4x over y. So that's our derivative. And remember, the derivative gives us the slope of the tangent line. So dy dx, or think of it like change in y over change in x, slope. So we have dy dx is 4x over y. We want to find it at this point. So I'm going to go ahead and substitute -1 in for x and 3 in for y. So we get a slope of -4/3.